So we have the first speaker, Xiqin Lucy Liu. She is PhD student at the University of Engineering, Science and Technology, China, and she will be talking about medial prefrontal activity at encoding determines the recognition advantage of threatening faces after 1.5 years. So Lucy, it's all yours.
Okay, hi everyone, I'm Lucy, and it's a great pleasure to present my PhD work here. So today's topic is about the neural basis, especially during encoding, of the recognition of threatening faces with a very long retention interval of 1.5 years. So faces are arguably one of the most important stimuli for social interactions. It contains a variety of information, including age, gender, and emotional expression. More importantly, it may transmit survival-related information. For example, when we see threatening faces, we might want to avoid it, and even in the very long future. So detecting and remembering threatening faces is extremely vital. Experimental studies have provided evidence on the threatening advantage from working memory, short memory to long-term memory, while the working memory and short-term memory showed consistent results on threatening advantage. But long-term memory advantage of threatening faces remains uninvestigated, especially with a very long retention interval. So here in our study, we address this question by designing a behavioral experiment and fMRI scanning. So basically, in the first stage, the participants were underwent fMRI scanning, during which they have to judge the gender of the faces. There were 5 emotional categories of the faces, including angry, fearful, happy, neutral, and sad, and the gender were balanced. And after like 20 minutes, they were asked to finish an immediate recognition test, in which they were required to determine if the presented face was an old one or a new one. Most importantly, we are interested in the long-term, in the delayed test after 1.5 years. So after a very long retention interval, the same group of participants were called back again and to complete another surprise recognition task and with another set of new faces intermixed. And to analyze the data, we firstly look at the behavior data by using univariate ANOVA analysis. And moreover, we were interested in the multivariate pattern of the behavior response. We specifically use PCA to decode the participants' behavior response. What's more, we, based on the behavior results, we look at the neural basis during the encoding that might contribute to the later recognition of the emotional phases. So the result, first, in general, we can see the participants successfully discriminated the old phases from new phases by the A' index. In two delayed and immediate tests that both showed a very higher level than the higher A' than the chance level. And the pair t-test suggested that the discrimination ability decreased after the 1.5 years. What we are more interested in is the emotional expression effect on the face recognition. So in the first step, we look at the main effect on the emotional expression in delayed test. And ANOVA showed a main effect. The post-T tests suggested there is the angry and fearful faces showed a higher or better recognition than the happy and neutral faces. However, the sad is just in between of the two, of angry, fearful, and happy and neutral. So these results indicated a long-term face recognition advantage of the threatening expressions on the face recognition. The comparison with the immediate tests further suggested that the recognition advantage of threatening faces was driven by the decreased recognition